Good afternoon, everyone. I hope you all had a good lunch. I'm glad you're still here. This is our last presentation today, and it will be about conveyor maintenance and the total cost of ownership. Our speaker today is Boyce Bonham. Boyce received his bachelor's degree in engineering from Arkansas State University and has been with the Hytrol Conveyor Company for 28 years. During his 28 years with Hytrol, he has served in numerous capacities, including manager of Hytrol's Technology Center, manager of quality assurance, director of systems development, and currently serves as director of integrated systems and controls for Hytrol. While at Hytrol, Boyce has been very instrumental in the development of innovative conveyor technologies that have changed the industry. He is an active member of the Conveyor Equipment Manufacturers Association Engineering Conference and has been quoted numerous times in material handling publications on various topics related to conveyors and sortation equipment. So would you please join me in a warm welcome for Mr. Boyce Bonham.
Thank you, Pete. Thank you for everyone attending today. It's been an exciting show. I'm glad we were participating, and hopefully everybody's going away with some great thoughts and new ideas to take back to your operation. Today we're going to talk about total cost of ownership. I think the key takeaway that I want to share with everybody is really lowering your cost of ownership goes beyond the initial investment that you make in the equipment. And just a little bit about Hytrol Conveyor Company. I've been with Hytrol for 28 years, and we're actually the largest conveyor manufacturer in Northeast Arkansas, or in North America. We're located in Northeast Arkansas. We're actually number one as far as the amount of conveyor equipment that we manufacture. And we go to market through partnering with integration partners throughout the world. And obviously McCombs-Wall is our integration partner in this area. And we do have long-term relationships with end users. Now what we're going to be talking about today should apply to you, whether you are implementing new equipment, a new automation, new conveyor, or whether you're upgrading or expanding existing equipment into your facility. What are some of the things that we should consider when purchasing conveyor? And what are my long-term costs of operating and maintaining that equipment? We're going to be talking about today, and also what can I do to control some of those costs through the technologies that are available out there today. A lot of times when people go into an investment, they go into it with sort of a limited vision as far as what their costs are going to be. And a lot of times there's actually more cost associated with a piece of equipment than just the initial investment. There's the long-term cost of operating and maintaining that equipment also. I break it down as far as the total cost of ownership as being obviously your initial investment that you've got to make, but then there's operational cost, there's maintenance cost, and all of that, there's a useful life expectancy of that equipment that's got to be factored into the equation. And what we look at is the initial investment plus your operational cost plus your maintenance cost, but you got to look at the useful life of that also, because sometimes you can invest another 3 or 4% in your initial investment and your useful life may be doubled. So you got to take that in consideration. How long is this equipment going to be effective in supporting my business? That's a major factor. Not just the life of the equipment from a mechanical standpoint, but is it going to serve the needs of my business and the growth that my business expects to have over the next few years? So if you look at initial cost, typically that's going to be your equipment, your controls, your installation. The operational cost, your electrical usage, your, if there's pneumatics associated with that, compressed air, that costs money. And also the maintenance cost. Maintenance cost consists of your spare parts to support the system, any replacement parts throughout the life of the system, and then the labor that's going to be put into maintaining that equipment. So let's talk about why the total cost of ownership is important. You have the initial investment, and then you have, that's pretty much constant over that life, and then you have the maintenance cost and your operational cost. if you could put just a few more percent into that initial cost and lower your maintenance cost and your operational cost, then over the life of that equipment, you can have a significant dollar savings year over year in what that equipment really costs you to operate and to support your business. So let's talk about the things that we're going to discuss today as far as controlling those costs. You know, the conveyor type, choosing the right type of conveyor, your controls can have an impact on that. The powertrain itself and the efficiency level of that powertrain we're going to talk about today. And then the adaptability of that conveyor to meet the changes that you expect to have or maybe don't even expect to have in your business. Does it have the flexibility and adaptability as your business changes? And then useful life. All right, so let's start off talking about the conveyor type that's chosen itself. The conveyor type, contrary to some people's belief, all conveyors not created equal. There's different types of conveyor, different types of technology, and they're all useful, but they're useful in different applications. So you got to make sure you pick the right type of conveyor to fit your particular application. Just a great comparison here of two different types of conveyors. One would be the one on the left that has a centralized drive system. That's a traditional type conveyor that everybody has known. 200-foot long conveyor. We've got a belt that's driving rollers or whatever, and one, 2 or 3 horsepower drive that's powering that in a centralized drive, driving a long length. The one on the right, some newer technology, 24-volt technology that really utilizes a decentralized drive system. So instead of having one high horsepower, high torque drive, you distribute the motors out throughout the conveyor. Here we show in little pancake motors. It's also done with what you've seen, I'm sure, many times in trade magazines and that sort of thing, and that's the motor-driven roller technology, where the motor is actually incorporated and embedded into the roller itself. So a centralized drive system versus a decentralized drive system. Each have purposes, and they both have a very useful purpose in different applications. So if we compare the cost of these, if you look at a centralized drive system, typically we see this as a lower initial equipment cost, but a lot of times the cost of supporting it from an installation, operation, and maintenance may be a little higher than the one on the right. The one on the right, in many cases, you may have a little bit more cost, a little bit more initial investment, but you save in installation, and sometimes that offsets that higher initial equipment cost. Plus, a lot of times it has a lower operational cost and lower maintenance cost, and we'll talk about some of those reasons why. Down in our booth, we have a piece of the what we call E24, 24-volt driven conveyor, but when the zone stop, you stop all energy consumption. Where with a centralized drive system, a belt's driving the rollers, even if the roller stops, the belts are still running, so you're still consuming power. But with the top on the right, if you've got a particular peak time during the day when a lot of your product's going through, you size your speed and everything to accommodate that. And during the slower periods throughout the day, those motors are going to be stopping, and you're not going to be using power during that time. So you're only using power when you're driving and moving product. As far as the next thing we want to talk about is the controls. The conveyor controls can have a lot to do with how much energy you consume and how much operational costs. If we can shut conveyor down when it's not being used, you're going to save energy in operating it, and you're also going to save in maintenance costs associated with that conveyor operating. So there's different levels of conveyor control. There's the warehouse level, there's the conveyor level, and then a zone level. We're going to focus today, for time's sake, we're going to focus on the conveyor level and the zone level. And what we mean by that, zones, a sleep feature. We hear of conveyors going to sleep. They shut down when product's not moving. You can do that in the zones if it's an accumulating conveyor and you got accumulation zones that may be 12 inches to 36 inches in length, depending on your product size. When product's not flowing through that zone can shut down. So it's saving energy, saving power consumption, saving wear on the conveyor. So that's a zone level. And then you can have a conveyor level where there's a whole conveyor in a pick module, say, or something, and maybe no pickings taking place in that area, no flows going through during this time of the day, and that area depicts that, and it shuts the whole conveyor down, saving power. And then another thing that's driving today and really being influential in saving energy and wear and operational cost is adjusting the speeds based on the need. You know, maybe you're designing this system to meet your throughput demands for 5 years down the road. But you know, today I don't really need it to run that fast. Through variable frequency drives, through speed changes, you can design it to run what you're going to need in 5 years, but running at a slower speed today can save a lot of cost in operating that equipment. And also through using variable frequency drives, it also helps a lot of times in the power factor when the building comes up in the morning when you start everything up. So through that, there's lots of ways to do that. And some of these speed adjustments can take place manually. Some of them can be through your control system and monitoring the flow and demand and adjusting speeds accordingly. Okay, an example of the sleep feature for a zone level and what that can mean to you in energy cost. All right, if it's a belt-driven live roller conveyor, your belt's going to be driving all the time. You're going to stop rollers in zones where product's not flowing, so you're not going to save a lot of energy in doing that because your main drive is still going to be running. So you may only save 10 or 15% in the actual energy cost because it's not going to be loaded as much. However, with a 24-volt conveyor, if there's times when you're not needing to flow a lot of product, the zones can go to sleep. With a 24-volt decentralized drive system, you're actually shutting power totally off to that zone level. So, your energy savings is directly proportional to how many zones have been shut off. So there can be a tremendous savings in power during that time. So, if I've got a system that, 1 or 2 hours in a day or half of the day, I'm going to be seeing my highest throughput demands, and I've got to have my conveyor designed for that time. But to say the other half of the day, I may be only running 25% of my throughput, and if I've got a 24-volt system during that time, wow, all of my zones are shut off, and that can be a huge savings for the energy. All right, from a conveyor level, this is an example of a project we did for a major book company up in the Northeast, and this had several benefits from shutting the conveyors down in certain pick zones. This particular system is a large distribution building, and when they started up, it took them about 6 months to really get full utilization of this conveyor because they just didn't have all the inventory put into here. So during this time, everybody's seen in warehouses where the lighting maybe shuts down when there's no activity in the zone and somebody walks into it, the lights come on. That's the way this system was designed from a control standpoint. When there was no activity in that pick zone, the conveyor in that pick zone shuts off. So tremendous savings in energy, but it's a lot of savings in maintenance. And for example, the first 6 months when they didn't even have everything up and operating, there was a lot of time, a lot of energy saved and a lot of maintenance saved in not operating those pick zones where there wasn't inventory and not a high demand of picking. So that can save a lot. Let's talk about the powertrain itself. I think there's lots of opportunities here. I like to focus on the efficiency level, and if you think about the maintenance, most of your maintenance to a piece of equipment is in the drivetrain. And there's some new things out today that can really save in the maintenance costs associated with the drivetrain, but also the energy used by the drivetrain. I think of the drivetrain as basically being the motor, some type of gearbox to cut it down to the speed you need, and then you typically got some kind of chain and sprockets or belts that transmit the power to the belts itself. in a centralized type drive system. You know, you can go with the top that's on the top where you got a motor, you got a gearing, and then you got you know, chain or something that's driving the gearhead, or you can go with something like on the bottom where you've got a direct drive, eliminating some of those power transmission components like the chain. In a, well, I'll get to that the chain part in just a minute, but from a motor aspect, you know, in the years past, and even still in some manufacturers, they're still using standard efficiency motors. Just going from a standard efficiency motor to an energy efficient motor can save you 3% of your energy consumption. That's pretty big. Then you can go to super efficiency and gain another 3%. Something a lot of people don't know is along with saving the power, you're actually getting a longer life motor also. And you're saving heat. You know, a higher efficiency motor is going to take the power and turn more of it into torque rather than heat. Heat's one of the biggest things that cause motor issues and motor damage. So just moving from a standard efficient to energy efficient, 3% energy, on over to a super efficient, 3%. I know we as a Hytrol conveyor company, a few years ago, we went to a standard energy efficient motor as standard, so there wasn't any upcharge to go to that because that's what we felt like the customer was needing. So along with energy efficiency, you're getting an increased life expectancy of that motor, and you're also getting a longer warranty on that motor. So that's a nice feature about going to a higher efficiency motors also. The next item is the gearbox itself. You know, there's lots of different types of gearing. The two most popular type of gearing that's used in the conveyor world is either a worm style gearing or the helical bevel type gearing. The worm type gearing varies a lot in efficiency, from 60 to 90% typically, where with the helical bevel it may be a lot closer to 100%, say 97, 98% efficient. That's all good. And increasing the efficiency of the gearing is not always directly proportional to your energy savings. With a motor it is. You have a 3% more efficient motor, you're going to have 3% energy savings in your electrical cost. But going from, say, a 90% efficient worm gear to a 97% efficient helical bevel gear does not necessarily mean that you're going to save 7% in your energy cost. And let me explain why. With typically the lower horsepower motors, 1, 2, 3 horse motors that's used in the conveyor world, the most energy is consumed in just energizing the windings of the motor. So if I take a 2 horse motor and set it on the shelf and run it unloaded, it's going to pull about the same amount of energy as if I set it on the shelf running under full load. So unless going to a higher efficiency gearing allows me to drop in horsepower size, I really haven't saved any significant energy. So my best bang for my buck is to put my money into a higher efficient motor, not necessarily into a higher efficient gearing, okay? Now, going to some higher efficient gearing can sometimes lengthen the life possibly of the gearing. So I'm not opposed to going to higher efficiency gearing, but if you're going to spend money, spend it on the motor, not the gearing. Synthetic lubrication is definitely a help. That allows any box to operate at a higher efficiency level and longer life, and you're eliminating having to change the lube out, so you're going to save some maintenance costs. Let's talk about the chain sprocket. How many in here has got a conveyor that's got chain and sprockets operating on it? Anybody in here got any conveyor? Anybody in here that don't have any conveyor needs conveyor? That's more important. All right, so, you know, there's a few different ways to do that. Typically, chain and sprockets, the popular way that conveyors are driven. There's ways to eliminate or cut down on the maintenance cost of chain and sprockets. Chain and sprockets is really your item on a conveyor that needs the most frequent maintenance in lubing the chain. That's really your highest maintenance item on a typical conveyor. That's got to be done on a most frequent basis, a chain sprocket. You can go with O-ring chain. O-ring chain is has sealed lubrication in the chain and can cut down tremendously on the amount of lubrication that you have to do, the time-consuming lubrication. So going to O-ring chains, one step you can go to. The next step you can go to is totally eliminate it by going to timing belt drives. But the best way to eliminate it, to totally eliminate that, is going to a direct drive. Anytime you can go from a chain sprocket over to a direct drive, you're saving maintenance costs and you're increasing your efficiency of your drive too. So, increasing efficiency, fewer components, and typically a higher initial cost is associated with moving from chain sprockets over to direct drive. However, this is something that we're really excited about. We're just introducing this product in June of this year, and that's what we're calling a unified drive system. The unified drive system is a direct drive system using a worm-style reducer that is high efficient. It's got a synthetic lubrication in it, and it's a long-life sealed reducer because it's a reducer that has there's really no maintenance associated with it because it's a sealed component, synthetic lubricant, no maintenance required to this particular gearbox, and it allows the elimination of the chain and sprockets. Where used to going to a shaft-mounted direct drive system might cost an end user around $1,500 to go to that, this is about a tenth of that to go to this style drive. So we feel like this is going to really help allow the end user to cost justify eliminating chain and sprockets. Going from chain and sprockets to this style drive, it's going to add most of the time less than 1% to the cost of the equipment, which is a pretty new thing. It's a really new thing that we're excited about in center drives as well as end drives. And you can just see you're eliminating chain and sprockets, eliminating the chain guard that's got to be maintained, kept in place, and that sort of thing, going to a direct drive, but it also eliminates the elevation and the space required for a chain style drive. You know, probably if I walk through a manufacturing facility and our distribution center, a lot of times the thing that I see that's gone unnoticed is chain rubbing on a chain guard or something. This is a big factor in eliminating that, which is a big plus. And even in some cases, like this belt conveyor, going from a chain sprocket application to a direct drive is actually going to cost the end user $0. This is a big thing that Hytrol is going to market with because nobody that I know of in the industry has been able to go from chain sprockets to direct drive at no additional cost. And that's what we're introducing in June. So what are the benefits of going to a unified drive like we're talking about here? It's, we've almost eliminated, in some cases have eliminated, the additional initial cost that you've known in the past. And at the same time, we've eliminated the drive chains, the maintenance associated with that, and lubrication, alignment, and tensioning, all that goes along with that type of drive system. No chain guards, no maintenance reducer, no lube that has to be changed on a regular basis. It's quieter operating and fewer spare components. So this is big. You know, and that's what we're looking for. If you go back and remember the diagram I showed you where you have an initial cost, and then you have a maintenance cost and an operational cost that build on one another. What we're looking to do is find ways to take the initial cost where there's no additional initial cost, but yet it's still lowering the maintenance cost and operational cost. I think that's the key of the game. That's when we can take the justification to a no-brainer. You know, fix it where the ROI is easily justified. And in this case, in some cases, no additional cost to be justified. It's just lowering maintenance and operational cost. Adaptability of a system. You know, that's an important factor if you're going to be buying equipment, buying conveyor. You got to think about the flexibility because my businesses change. They're changing rapidly. Your volume, your products are changing. you got to consider how flexible your system is to be able to change with your business. Product size changes. We all know that's a big factor that we've watched over the last 3 or 4 years. Product sizes dramatically decreasing in size because a lot of direct-to-consumer business. And throughput changes because, you know, it's hard to predict what my business is going to need throughput-wise 5 years down the road. I got to make sure I'm investing in equipment that can adapt to those changing needs. Can your conveyor system be configured on demand to meet those changing requirements? So, you know, the product sizes changes. Some of the things that we've incorporated into our equipment is the ability to change the zone length. Used to, we had, if it's an accumulating conveyor, we had to size the zone length to fit a product size. Today, we have, through our control system, Easy Logic, it can measure the length of the product and assign the appropriate number of zones to that. So if I buy a system, say 10 years ago, if I bought a system designed for my 24-inch long cartons, and 3 years down the road, my carton size changed, maximum carton size changes 3 feet, I'm not going to operate a system very well because I didn't design it for that 3-foot long carton. Today, conveyors are intelligent enough to see my carton size, assign the correct number of zones to that cartons, and it doesn't lose efficiency or effectiveness in conveying the product. Different release modes are available today so that, you know, if I put in today a system that's going to be handling 30 cartons a minute, and 3 years from now I need to be handling 60 cartons a minute, I can change to a different release mode in many cases and be able to handle that higher throughput on the same conveyor, even in some cases at the same speed. And also, you know, the ability to change carton destinations and sortation, changing throughput requirements. All of our sortation equipment have variable frequency drives in it for that very reason. I don't want to run my conveyor today in sorting my products. I don't want to run the speed that I need to for my 5-year plan. I want to run them the speed that I need for my demand today, saving energy, saving wear and tear on my equipment, and therefore saving maintenance costs. So configurable accumulation control, this is something that we introduced a number of years ago through our Easy Logic control system. The intelligence is built into the photo eye itself, and it can be configured through a PC so that we can change the timers on it, we can change the throughput on it, even a lot of times in keeping the speed the same. So it allows an intelligent control, but a configurable control to adapt to my changing product sizes and changing product throughput. Some of the key factors is, you know, cascade release. I've underlined a few of the key things. Cascaded release is a control function in our zoned accumulation conveyor that really allows you to run your conveyor slower, keeping your throughputs high. You know, used to people always talked about speed. How fast can I go? The days of how fast can I go is not really the thing we need to be talking about today, because running conveyors fast, it's higher maintenance, higher wear, higher energy. So what we need to be talking about is higher throughput, not higher speed. So what we've designed in the end, and the innovation of today's conveyor, is driving the throughput while keeping the speeds lower. You don't see as much empty space on conveyors today. Some of y'all saw some of the videos this morning maybe of some of the jobs that we've done with McCombs-Wall, and you see cartons with not much gap between them. You know, gap drives the speed higher, and it's just wasting energy. How long will my system last? Useful life, that's a big factor. Useful life, and not only how long the design life of the equipment itself is, but also how long is it going to be useful to my business? Can it grow to adapt to my increasing needs in my business? So reliability, that's important. Reliability of components. You got to make sure that, and it's okay to ask up front, what is the design life of this piece of equipment? That's an okay question to ask. You ought to be asking that kind of question. What about the manufacturer support? You know, am I going to have availability of parts? I've seen equipment obsoleted because the company I bought it from was no longer in business. I could no longer get spare parts. I could no longer get replacement parts. So you got to make sure that, you know, what